Hey guys, so I wanted to make a quick video correcting something, a mistake that I made in my previous videos, or maybe you would call it just a mix-up or a misnomer. In a few of my videos, I'm using the phrase translation invariance, and I'm confusing translation invariance with uh, translation equivariance and permutation invariance, or actually more appropriately permutation equivariance. So basically, a CNN is translation equivariant, which means, okay, so what I was trying to do is describe why ResNet 18 has inductive bias and why it might be better to use a model that has inductive bias on a data set like CFAR10, and why that might converge to a higher validation accuracy more quickly than a vision transformer. And that conversation of inductive bias brings up the terms permutation or positional invariance or permutation equivariance, which both of those terms apply to a vision transformer or a transformer in general. And then on the CNN side, the terms translation equivariance and local receptive fields apply. So a vision transformer without positional encodings is position unaware, or you can say it's position invariant or permutation equivariant, which means no matter how you permute the patch embedding, so you turn an image into let's say you get 8x8, extract 8 patches, height and width, 8 times 8, 64. You get 64 patch embeddings, and then you send those to the query's keys and values. As long as you permute it the same for the query's keys and the values, as long as the patch embedding input is permuted the same, your result is going to be the same, right? So it's permutation equivariant, which is why the model has no inductive bias, right? It's related to the fact that the model has no inductive bias. It makes no assumptions about the data until you add until you make the model the attention mechanism position aware by adding position embeddings. But even then, it's adding a little bit of bias, inductive bias. It's making some assumption about the data. It's saying that this patch embedding is here and this patch embedding is here, but that's a very small assumption you're making about your data, as opposed to a CNN, right, which uses local receptive fields, right, which is essentially your kernel, right? Your kernel looks at a patch. It looks at an k by k tensor, or a k by k square of pixels, right? And the assumption is that the closer the pixel, like all the pixels in this local receptive field are likely to be related to each other, and the closer they are in space, the more likely they are to be aware of each other. And then you take this kernel that looks at these, that slides along these local receptive fields, and it also at the same time uses the same weights to calculate the dot product across these local receptive fields, right? It uses that, it creates these, there are these blocks that are based on this mechanism, and it takes in an input and it gives you an output based on these sliding kernels across with these shareable weights across these local receptive fields that make this assumption that pixels that are closer to each other are more likely to be related to each other. And that's when you stack these blocks on top of each other, that's how it builds more and more abstract features, right? So the whole functionality of a convolutional layer or a network that's based on convolutional layers is based on that assumption, which is inductive bias. And just to clarify the term, I for some reason I was confusing translation invariance of a vision transformer, which is not the correct thing to say, with translation equivariance of a feature mapper or a kernel, right? Like of a convolution, right? Which is translation equivariance is if you shift the object, if you shift an object in the image, the object in the feature map should also shift. But what it really means is no matter where the object, like let's say this feature map detects an eye, no matter where this eye is in the image, the feature map should, result in the same numerical value, in a basically the same numerical value, right? Because it's a dot product, it's calculating a dot product. So that's what translation equivariance is. Translation equivariance is no matter where this object shifts in the image, the feature map will be able to detect it the same, or the kernel will be able to detect it the same. So, yes, wanted to clarify that.